Hi, everyone. Welcome to Konveyor Meetup. My name is Jonathan Racinos, and today we have Steve and Joe from VMware who will be presenting and demonstrating the Cloud Suitability Assessment tool. Before I hand it over to them, just want to go over a few things. So first of all, if you're not part of the Google group already, you can sign up at konveyor.io, click on forum, and then just click on join group. This way you get invites to future presentations, you get the recording of each presentation, and you stay up to date with all our community tools. And as for today's presentation, if you have any questions, feel free to put it in the Q&A, and Joe will help out with that. And then at the end of the presentation, we'll also go ahead and link to the actual survey to get feedback on this presentation and just give you guys a chance to help us mold these in the future. So Joe and Steve, I'll hand it over to you guys.
All right. Hi, everybody. Nice to meet everyone. Let me share my screen here. We have a short little presentation, and then we'll go into the demo of the Cloud Suitability Analyzer. The Cloud Suitability Analyzer is a tool that we've developed to help answer a bunch of questions that people have when they're doing portfolio analysis. They're trying to migrate applications into modern architectures, and some of the questions they have are kind of big general ones are, what's in my code base, for example? So in an enterprise that has thousands of applications, lots of times people don't even know what actually is existing in their code base. They have really old applications, they have really new applications, they have high turnover. They're just trying to find out what the heck is this animal that we're even dealing with. Another one is we know we want to move applications to a cloud architecture, container, or make them more cloud native, whatever you want to do, but how technically feasible is that actually? There are applications that can be moved. There are applications that shouldn't be moved. Is it even possible from a technical perspective to migrate this application? The other one is, how do you actually do this stuff reliably and quickly, right? There's a lot of ways to do it, but people basically in these migrations and modernizations, they want to go fast. The basic goal is, how do I do all this stuff with a very large code base very fast? What we really need is a rapid way to make informed decisions regarding the cloud suitability of applications. And the key word here is rapid and informed. So instead of just guessing, we want to do information based on analysis, real world knowledge, and do it quickly. So how do you answer those questions? You have a couple ways. You can do manual, right? You can start cracking open the code, finding experts, looking into each application, and relying on their knowledge. This obviously is pretty slow and it's very inconsistent. As I mentioned previously, most enterprises have people who've moved on or haven't touched an application in years. So getting accurate knowledge is not the way to go. The other way is to have some type of automated rule-driven analysis engine that has the capability to scan millions of lines of code automatically. It is built on a set of rules that have been field tested. So people have actually done migrations and looked for patterns within applications, having coded that into an analysis tool, and something that you can obviously customize, right? So it's not just here's a set of rules that someone gives you, but something that is also expandable. And that's what we've done with Cloud Suitability Analyzer. But before we get into the actual details, I just want to take one step higher and talk about how we look at dispositioning a portfolio of applications. We want to make a business model, a funnel, a decisioning model that has multiple characteristics, it looks at multiple perspectives to decide which applications to move. The technical considerations are what we're talking about with Cloud Suitability Analyzers, what can be modernized, right? These are technical things, architectures, whether it's stateful, it's how it's designed, dependencies, workloads, that type of thing. And then there's the business aspect is what should be modernized. So just because you can modernize something, just because it's technically feasible, doesn't mean that you actually should do it. So this is another perspective of that decision-making model. And the third one is just when should you do it, right? So it's can you do it, should you do it, when you do it. And then that leads you down to a bunch of dispositions. Should you retire something, retain it? We're mostly focused on rehost, migrating, and replatforming. So rehost means to move to a different operating system, a different environment, and replatform means to move to Kubernetes or to start making it more microservice or cloud native. And Cloud Suitability Analyzer, Cloud Suitability Analyzer focuses right in this technical realm here. So we're not looking at business value or anything like that. We're purely looking at technical patterns. And some of the use cases that we've seen with this is obviously portfolio analysis is the main one, where people are looking for candidates within their portfolio of applications to migrate to a new environment. We're using it to assess technical feasibility. We've also seen people use this tool in their CI/CD pipelines for continuous suitability monitoring. We just made that word up, but that's what customers are actually doing. They've taken applications from legacy environments, they move them to modern environments, and they run Cloud Suitability Analyzer on it in their pipelines to say, is it maintaining a minimum level of suitability? So is the application degrading? One of the environment owners classified it as he doesn't want any more crap on his platform. So once someone gets onto the new platform, he wants to keep all the crap out of it. So they run the tool in a CI/CD pipeline. We had another use case as well too, since we'll show you that it is a pattern matching rule engine that people have used this tool when they are upgrading applications. They're upgrading applications, and as some of the applications and libraries that they're using are deprecated, they actually write rules to find those deprecated or things that don't comply or need to be upgraded in the application, and then the clients or the customers run that to find out the things that they need to keep up with the latest versions of application. And then there's the general questions of situational awareness. What's in my portfolio? How big is it? What type of technologies are being used? And it's a rule-driven engine. So the rules are pattern matching rules. They're written in YAML. There's 3 different types of rules, or 4 actually, but they have regex rules, XPath, and you can write JSON path as well. And it's basically just a YAML file. It looks for a pattern. When it finds the pattern, the rules fire. We're actually also upgrading this currently right now to have negative rules. So we're looking for the non-existence of something, if you can wrap your head around that. But we're doing that as well too in the rules. And the rules each have, within that YAML definition, they have a score. And we take that score and we combine all the scores for each rule. The rule types have different scoring values, different ways they're scored, and Steve will get into that deeper when we talk about the demo. And then we take that score, we run some statistical analysis on it, and so we get a nice smooth distribution, and then we drop the score down to between a 0 and a 10 for cloud suitability. Anything around that below 6 is pretty tough. It's going to need a lot of work. Anything above 6 is going to need somewhat work. Things that are 10 are just piece of cake type of things. And the way we came up with these rules is we have about 2,000 rules in there currently. So Steve and I are involved in an application transformation practice, and we've taken from our years of experience of migrating applications, as we were migrating applications, looking for things that made it easier or hard or need to be changed. Those are all written down into a cookbook. We've taken that cookbook of thousands of recipes and we've codified them into these rules into the Cloud Suitability Analyzer. And I mentioned it's fast. It's pretty fast. We've actually ripped through about 5 million lines of code in about a half an hour in some situations. So it's written in Go. It runs really fast. It can do a lot of analysis really quickly. And we'll go right. I'm going to switch over to Steve now, but I also wanted to mention that in addition to the rules that we have codified, we also have the ability to create custom rules. So you can write brand new rules. You can write different types of rule sets, so you don't have to run all of our 2,000 rules. You could only run 10 of them if you wanted to, or you could run a complete new set. I will stop sharing. I get back to that screen, and I'll hand it over to Steve.
Thank you, John. Okay, Joe mentioned that all the rules are just YAML. Here's an example of a rule. Basically, they're fairly easy to write. As you'll see in a minute, there's a lot of techniques you can use to import, export, modify rules, create rules of your own. They're just YAML. In this particular case, this is a rule that you're seeing that looks for Java file I/O. So we have a regular expression here that %s is going to be substituted with these patterns down here. So what we're looking is the method calls that indicate some sort of file I/O is taking place. Of course, we want to know if file I/O is taking place because that has implications whether you're going to the cloud or whether you're going to go into the container. And that's just one example of the rules. Now, all these rules are actually contained in a single executable. As Joe mentioned, it's written in Go, so we have a Linux, we have an OS X, and we have a Windows version. Let me switch over here to the to terminal. If I have CSA installed here. This is the OS X version. If I do a list, it's all by itself, a single executable. Inside that executable is a web UI, and also a database is going to be created. And we'll come back to this directory after I've run it. Over here in this window, we have just a set of subdirectories. All I've done here is I've gone out and did a git clone to 3 different applications that I found on GitHub, and I've just cloned them. That's all I've done. So each of these directories is just a directory full of source code. If I go down here, they're in the demo apps directory. Come down here, I can run CSA. I'm passing in the P switch. There are a lot of different capabilities on the command line. This is a fairly extensive set of capabilities. It can be seen if you come up here and do CSA and do an H. You see it has quite a few command line capabilities. We won't go into all of these today. We're going to just cover a couple. One of the ones we're going to cover today is just to run CSA on this demo app. I'm doing a -P, and that's telling CSA each of these subdirectories is actually part of a portfolio. So it's going to run in portfolio mode. Then we just hit enter. It's going through. Now, if you were here, you'd hear that all the fans kick on. If you're scanning a fairly large portfolio, it will saturate all the CPUs. That's the reason it runs so fast. It'll give you some information here on the command line. You see the scores. We had one at 8.96, 6.5, and a 5.25. It gives you some stats here. So you can actually get quite a bit of information just on the command line. And Joe mentioned some customers are actually running this in their pipeline, and they're just going through and parsing out this stuff to find particular things that they're interested in their pipeline. Now, if I wanted to see the user interface, all I do is come back here and just type UI. So it brings up, it's actually running a web server inside the executable. Now, if I go back over here to where my application was and I do a list, you see it's actually created a CSA.db. That's a SQLite database. It's also produced a YAML file that contains different information about that particular run. Every time you run it, it creates a new run number. So if I go back over here to the web browser, you come up here. If I'd run it multiple times, I would be able to select those multiple runs here. Give you a little bit of information about about who ran it, the date they ran it, the target that they use, and the runtime. In this case, is about 4 seconds. This is a summary screen. We have different screens we'll get to, but the summary screen here is just kind of list information about the entire portfolio. We scan 3 apps. Typically, this is in hundreds, sometimes even in the thousands of applications. We envisioned it basically. Customers would kind of line of business would pull down all the applications to a single directory, and that line of business, it could be a dozen, it could be 100, it could be several thousand lines of code that it found, the total number of files, total number of findings. This is basically the number of rules it fired. So in this case, 1,712 rules fired. Here we have the different applications that we've scanned. We can go over here to a portfolio view. We'll get to each individual application in a moment. But here's a portfolio view. It's going to show us the top 5 languages, the top 5 API calls. In this case, it's primarily JBoss that we're finding. Down here, you can select a particular language. You wanted to see the distribution of that language. Let's say select Markdown here. It'll give you a little bit of a distribution about that. And same thing with API calls, metrics, logging. Gives you the kind of distribution. You can hover over there and you'll see the detailed information. Now, this is kind of give you an idea of the portfolio view, what the composition is. If you want to go into individual application, you select this screen, and you can select the individual applications here. I'll get some more into these boxes and oval shapes here. Basically, the oval shapes are the actual rules themselves. The boxes are kind of, you might think of them as archetypes. So they actually, if I click on one of these, let me go ahead and select a different application here. Let's go down here and select this one because I know this is pretty rich. And if I want to come in here and see what TKG rules fired, that's our Kubernetes. It shows which rules fired. I click off on that. TAS, which is our cloud base, the things that it found for there. container. Since we've come to VMware, we've written a lot more container rules. So these are the individual rules that are fired for a particular container, and so on down the line. You get the idea. If we scroll down here, you'll see the actual rules themselves that are fired. If I hover over each file, it'll actually show the path to that particular file. And if I go over here, you can do a lot of sorting and searching. Each of these screens you'll see. You can also export CSV files. And if we click here, that kind of gives you some information about the rule. And each of these rules, this is basically the YAML file being re-rendered here, so you get some idea about the rule that fired. And it's very, very extensive as far as the amount of information it's providing you. The idea here is, okay, so I got a bad score, and I got 6.55 is kind of marginal. If I hover over that, it'll show you the raw score. All metrics that are taken from source code typically are log normally distributed. And so we do some processing. We basically are taking a logarithm of the score and doing some additional processing and subtracting the overall score from a 10. So these typically hover between, for most portfolios, it's fairly rare to get below a 4. Typically, they're going to fall between a 6 and a 10. And like Joe said, if they're closer to a 10, like a 9.5 or even an 8.5, they're probably going to be fairly easy to get into the cloud setting. But like I said, we have container rules too. So we're actually looking if it's already partially containerized or fully containerized. We're doing some additional scanning and processing rules to see how well that is containerized. Now go over here to the data slot. And this is all the different, this is kind of a pivot point table here, all the different kind of rules that we're processing. We kind of scroll across here and you see the basic composition. So you're not only interested in the score, you want to know why it got that score and what kind of work you're going to have to do, what skill sets are involved to improve that score. If we go into the API usage detail, this is a very detailed list of all the different rules that fired. And go to the API usage summary. Like I said, this is mostly JBoss. This is kind of gives you a summary level view of all the different types of rules. If there are some dangerous annotations, they will be found here. Third-party libs, they're found here. In this case, we see a com.sun. Source code, this is very important because many times customers are scanning rather old portfolios. They might find that they didn't know that they had some Ruby in there or maybe some Perl. So it's a good indication to see exactly what kind of file metrics you have there and what the composition, what we think of as the anatomy of the application. Go over to here. This is every finding that we have. And if you do write your own rules, this is a rule by app. You can see which one's fired here. This is breaking down to the rule level. And if you do start writing rules yourself, you would want the performance metrics. Sometimes if you're writing a rule, you might write a regular expression that's particularly poorly written, and you can see which ones are slowing the process down here. And if you wanted to get really detailed over here and you start authoring rules, this is all the different rules that we have in the entire system. If we were to go over to here into the terminal view, there's tons of command line options to allow you to import your own rules. You can either overwrite the existing rules, you can export the rules, maybe you find some that are close to the ones you want, and just make a modification to that and re-import it. So we have a lot of customers that are actually maintaining a GitHub repo of their rules and doing a script where they're kind of pulling them down, importing them either by themselves or overriding the existing rules, and like Joe said, running it in a pipeline. And let me go back over here to the summary screen, and I'll pause there, see if we have any questions.
I think we're fine, Steve. I don't see any questions right now.
Okay. And this is an open source project, so if you go out and Google Cloud Suitability Analyzer, you'll land on our GitHub account, and you can download it and examine the source code yourself.
Yeah, guys, and that link is in the chat if you want to get to it. And that was awesome, Steve. Thank you so much. I didn't see any other questions. We'll give a few more minutes or a few more seconds at least.
Okay.
Here's here's a question. So Phil is asking, what is being analyzed? Is it the source files or is it decompiling the application archive files?
Oh, good question. We do have the capability to decompile, and if you run it with that switch, it will decompile it. So we can look at jar files, war files, and ear files. Sometimes customers have more access to those and they have the source code. Sometimes it's difficult to get the source code for various different reasons. So we do have that capability to decompile those and run it on those files.
Okay. And go ahead, Joe.
It is primarily a source code analyzer at this point. So this tool was born out of necessity when we were doing large portfolio analysis. So instead of doing it manually, it started turning into scripts and turning into applications. So there are ideas.
We would land on the customer's site, and it'd be maybe a 4-man team, might be 4 to 10 of them, and had a dearth of applications. So why can't you give us your applications? Well, we have hundreds of them. We can't figure out which ones to do first. Y'all probably heard that story too, right? Here are twiddling our thumbs. Give us some applications. We don't know which ones to pick. So we wanted something we could throw over the wall to them and let them run it on their own, because sometimes customers are very sensitive about seeing source code. So we don't want to see your source code. We just want to see metadata about your source code. That's how we're going to make our decisions. So it kind of breaks that log jam. We can't see our source code until we figure out what to do with it. So it kind of gets the ball rolling. That was kind of the whole point of building it.
And we do have some more. So Richir is asking, have you given some thought to statistical modeling rather than rules?
What was the question? What did I hear the last part?
Have you given some thought to statistical modeling rather than rules?
Yes. As a matter of fact, we're working on a new version now that's going to be a little bit more elaborate in the way it parses the code. And that's exactly what we're considering doing, is actually building it in a graph database, so that the code becomes a kind of a knowledge base, kind of a graph knowledge base, and then being able to, after the fact, run any kind of query we wanted to. It's basically taking the abstract syntax tree and the packages that are being used, and building a model, and then using that model to make further decisions on. As a matter of fact, building a model that could possibly encompass the entire portfolio, and there's all sorts of doors that open when you have a graph database like that.
Okay. And then the next question is it Java-centric, or does it cater for other programming languages?
It can build. Yeah, go ahead, Joe. You can answer that.
Yeah, so as we said, it's a source code pattern match application. So anything that you can write a pattern for, it can have a rule for. So for example, as I mentioned, some customers people have implemented where they're looking at configuration files to see if their configuration of an application meets the current application's upgrade path, or things that are deprecated or not. So it can look at JSON files. It can look at, it can use XPath. It can look through XML files. The rules that we have that come with it, that are codified, though, are primarily Java and .NET for the most part, because as we dealt with enterprise customers, they are the 2 largest portfolios. So it's probably 2/3 or probably 2/3 Java and about 1/3 .NET. But if you can write a pattern for it in XML, JSON, or just a regular expression, you can use it to find stuff.
Yeah, and the way we suggest when customers do that, if you can write your own rule set, let's say you can write a rule set for Python, you would start with what's the most egregious thing you find in a Python program, what's the most horrible thing you could possibly find, write those rules first, and work your way down to the less impactful patterns you could find. So like write the first 10 rules of the worst things you could possibly find in a Python program, write those rules first.
Okay. And I'm just going to tackle this question because I've seen it multiple times. The question is, how does CSA interface with Konveyor? So the answer is right now it does not. Right now, Joe and Steve are just showing this at a Konveyor meetup, but it does not actually interface with Konveyor at the moment. And I think that's all the questions. I don't see anything else. Steve and Joe, thank you guys so much for presenting. Everyone seemed to be very fascinated by this tool. And for the rest of everyone, thank you guys for coming. Steve and Joe, any parting words that you guys want to say that any way we can help you?
Thanks for the invite. It was a pleasure presenting.
Yep, thanks. Same here. Thanks for the invite. And we have some more cool stuff coming out down the road that's going to be open source too. So keep an eye out for that.
Okay, awesome. And to everyone else, I'll send out the link to the GitHub repo that Steve and Joe shared. All right, guys, enjoy the rest of your day. Bye.
Thanks.